Hi, my name is Joshua Bartkoske. I am a second-year grad student here at the University of Utah, working with Dave Kita and Benita Hona. I spent the summer, funded in part by the Swigart Scholarship, looking at the high-mass X-ray binary LSI 61303. And today I'm just going to go through some of the data and analysis that I did over the summer and what my steps are moving forward. So over the summer, I looked at this binary, which is made up of a BE star and a compact object, which we don't know what exactly it is. We think it could be either a neutron star or a black hole, but I'll talk a little more about that later. It's been observed in the radio band as well as other bands all the way up to gamma ray. And it's exciting because it's one of only 11 high mass X-ray binaries that's also observed in the highest energy bands in the gamma ray spectrum. And so I used data in the gamma ray, high energy gamma ray, using these two different telescopes. One of them is a partnership that we have with the University of Utah called VERITAS, the Very Energetic Radiation Imaging Telescope Array System, as well as data from MAGIC, the Major Atmospheric Gamma Imaging Cherenkov Telescope. And using the data from both of these, I constructed a light curve seeing fluxes over 10 years that then I was able to analyze and try to fit an orbital period to, ranging from 15 days to 35 days with a step size of 0.1 days in there. And so for every one of these periods, I would phase fold the data and then weight each bin for the phases and try and correlate it with the actual data that we collected. And so I used a Pearson correlation coefficient in order to establish how well each orbital period fit the data. And as you can see here, the peak is at 26.5 days, which is pretty nice. And I'll explain more about that on my next slide. But one of the cool things is that it's a PCC of 0.7, and it seems to be at least somewhat significant in this case, but I need to do some more work. So in my analysis, like I mentioned, I found that at 26.5 days, the PCC is 0.7, which is the highest value between 15 and 35 days. And this is very close to the established orbital period of 26.496 days that has been found first in radio and then at other wavelengths as well. But I don't know how significant my result really is. And the part of that reason is that this could just be a statistical fluctuation. And so I'm going to be doing an analysis to look at whether or not this peak is real. And that's going to be using a toy Monte Carlo simulation to get more simulated data, and then run this analysis many times on the simulated data to see if this result is actually significant. And once I do that, the goal is going to be then, and even now as I'm learning more about the source, to understand the science behind this. Because the compact object still has an undetermined nature. It could be a neutron star orbiting the BE star, or it could be a black hole orbiting the BE star. We don't know which scenario is correct. And so this is one of the things that we want to understand more of with the data that we're collecting. And hopefully in the future, by understanding one of just 11 of these binary systems in the universe, we can understand more about these extreme environments and also understand more about maybe the physics that's going on, the geometry, how we're observing things, and improve our understanding of what this object is. But that's still down the line for me. For now, I'm just going to focus on the data. And if I get any new results, you can tune into another conference coming up or some other meeting that might be happening. Thank you so much for your attention. Again, my name's Joshua.